All right, now we're going to work on simplifying with all types of radicals. Now we already have practice at the beginning of the year reducing square roots. So let's just do a little reminder there. Writing the square root of 45 in its reduced form, we're going to look for the largest perfect square that divides into 45, and that's 9 times 5, so that's 3 root 5. For number 12, largest perfect square that divides into 48, that's going to be 16 times 3, and that gives me 4 root 3. Now, remember, we thought of the largest perfect square that divided into the radicand. Let me remind you, the radicand is the number inside the radical. For number 13, the cube root of 48, we need to find the perfect third root of 48, or we need to factor it into a perfect cube times the remaining factor, just like we did with the square roots. Well, that means we need to have a list of perfect cubes. So perfect cubes, let's go ahead and create that. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. I'm going to go ahead and stop there for now, okay? And now I'm going to see which one of these numbers divides into 48. And that would be the number 8. So that means I'm going to take the cube root of 48 and I'm going to rewrite it as the cube root of 8 times the cube root of 6. 8 is a perfect third root. Sorry about the doorbell barking there and the dog barking. So the cube root of 8 is 2, because it's a perfect cube, with the cube root of 6 remaining. Very similar to what we do with square roots. Let's talk about other nth roots, like the fourth root of 48. So now I need to generate a list of perfect fourths. In other words, integers starting at 1, where you multiply it by itself 4 times. So 1 times 1 times 1 times 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. 4 times 4 times 4 times 4, we did that one earlier, that's 256. Now we can stop because the number under the radical is a 48. And so what we're going to do is we're going to factor, so the fourth root of 48, notice it's the same number as in number 13, but we're looking for a perfect fourth root. So we see that 16 divides into 48 3 times. The fourth root of 16 is 2, with the fourth root of 3 remaining. So when you're working with square roots, cube roots, fourth roots, we're always looking for that largest perfect root that divides into the radicand. When you're doing operations, add, subtract, multiply, divide, here are your rules. When you're multiplying or dividing, you multiply outside to outside numbers, inside numbers to inside numbers. The same is true for dividing. When you're adding and subtracting, you must have the same number as the radicand. So you might have to reduce the radical in order to add or subtract. For number 15, those are both cube roots. And so therefore we are able to divide the 3 into the 96. So 3, notice I'm not using, divides into 96, 3 times 32. So this becomes, oh, it's not the cube root, it's the fifth root of 32. And we've already done that one. We're looking for the integer that when you multiply it by itself 5 times, you get 32. So that's 2. Number 16, those are both cube roots, but we don't have the same number as the radicand, and so we have to break them down. So I have the perfect cubes listed over there at number 13. So which one of those perfect cubes divides into 81? So that's going to be 27. So that means that's going to become the cube root of 27 times the cube root of 3. Because 27 multiplied by 3 is 81, and 27 is a perfect cube root. That's going to give me 3 with the cube root of 3 remaining. Now let's break down 24. Which one of those numbers divides into 24? 8 does. So that's going to be minus the cube root of 8 times the cube root of 3. So that's going to be minus 2 cube root of 3. So now let's remind ourselves, we have the same radicand. So the rule is when you're subtracting or adding, you leave the number inside the radical alone and you add or subtract the numbers in front. So 3 subtract 2 is 1. So that's 1 cube root 3, or you could just write it as cube root 3. For 17, we're multiplying. And when we're multiplying, we do not need to have the same number inside, okay? And so we would multiply the 12 times the 18, and we would multiply the 2 times the 5. So 2 times 5 is 10, and then we have the cube root of, and then we're going to go ahead and do 12 times 18, okay? So now 12 times 18, I think that I will go straight to my calculator for that one. So 12 times 18 is 216. All right. Well, 216 happens to be a perfect cube. In fact, I didn't put it up there, but I can add one more. 6 times 6 times 6 is 216. So that means that this problem can simplify to 10 times 6, which is 60. Last one. They're both cube roots, and so I can divide 9 into 18 2 times. So cube root of 2, and nothing else to do with that.